As we continue to explore the galaxy, one of the most exciting possibilities is to find planets like Earth that might host life. For the past many decades, this search has led to the idea of colonizing the galaxy. But is it possible to make this fantasy a reality? Stay with us till the end. We answer this question and explain what humanity needs to colonize the entire galaxy. The habitable zone. It goes without saying that Earth is the only planet in our solar system with a breathable atmosphere and the ideal distance from the Sun, and is uniquely positioned to support life. Quite obviously, one of the major obstacles to colonize other planets require us to locate planets that are comparable to Earth in terms of size, composition, and atmospheric conditions, among many other things. Even though the hunt for habitable extrasolar planets is still in its infancy, the discovery of hundreds of potentially habitable planets has already created a host of intriguing possibilities for the spread of human colonization into the future. This is why the researchers are actively exploring the possible planets that orbit in the habitable zone of their star. The habitable zone is an area surrounding a star where conditions are ideal for liquid water to exist on a planet's surface. Finding planets in the habitable zone is an encouraging indication that they could support life because water is a necessary component for life. After this, the size and makeup of a planet are further considerations, as planets that are too massive might have a dense toxic atmosphere that could make it difficult for people to breathe, while planets that are too small might not have enough gravity to hold onto their atmosphere. Moreover, in contrast to gas giants like Jupiter or Saturn, scientists search for planets with a solid surface. One such example of a habitable planet is Proxima b, which revolves around Proxima Centauri, the star that is nearest to the Sun. Quite interestingly, Proxima b is around the size of Earth and orbits its star in the habitable zone. The planet is an intriguing subject for further research, even if we are unsure of whether it has a breathable atmosphere or liquid water. Another example of habitable planets is Kepler 452b, which was found in 2015 by the Kepler Space Telescope. Kepler 452b circles a star that resembles our Sun and is about 60% bigger than Earth. Furthermore, scientists need to send in probes to investigate and gather information about the planet's atmosphere, composition, and possible habitability. The all-new James Webb Space Telescope is currently being used to investigate the atmosphere of many of these habitable planets and search for indicators of life, such as the presence of oxygen or methane. Colonizing planets. After finding a habitable planet, the next difficult task is to colonize it. This would require building a self-sufficient habitat that can accommodate human existence in the planet's environment. Not only this, air, water, and food would need to be available, as well as shelter from the environment and any potential dangers on the planet. Many scientists have presented theories that a good option to do all of this is to build underground dwellings that can shield people from the hostile atmosphere of the planet. This would entail drilling into the planet's surface to create tubes and chambers, as well as using cutting-edge materials to maintain the structure. The habitats could potentially be made to produce food and other essentials using local resources like water and minerals. However, this won't be as straightforward and easy as it sounds. Colonizing other planets will come with a number of significant difficulties. One of the biggest of those difficulties is the fact that the universe is massive. That is why we can't just send people across such vast distances in a spaceship, because a spaceship is too impoverished an environment to sustain humans for the length of time it would take to reach another planet. To give an example, Alpha Centauri, the nearest star system to us, is more than 4 light-years away. To put that into perspective, NASA's Parker Solar Probe would need to travel for nearly 6,000 years to clear that distance. Mind you, this time is just to get to the closest star system, and it would require significantly more time to travel to other stars in the galaxy. This leads us to the idea that we would have to build some sort of space-traveling ark, big enough to house a community of people and other plants and animals in a fully regenerative ecological system in place of a starship. And that ark would need to be compact enough to accelerate to a pretty rapid pace, reducing the amount of time the travelers would be exposed to cosmic radiation and malfunctions. Another solution to this problem is that we somehow build a really fast ship. The NASA Juno probe which is now the fastest spacecraft mankind have ever created, orbits the Sun at a speed of about 265,000 kilometers per hour. Even though that is incredibly fast in comparison to what we are accustomed to on Earth, it is still a very small portion of the speed of light, which is the universe's known maximum speed. So, it is quite clear that we would need to create considerably quicker spaceships in order to make interstellar travel possible. Unique approach. Another solution to this problem is by employing a unique propulsion method referred to as a solar sail. Using solar sail, a spaceship can be propelled by the energy of the Sun, which quite obviously is very large, thin sail constructed of a reflecting material. This can theoretically help us someday attain speeds close to the speed of light by progressively speeding a solar sail over a lengthy period of time. While solar sail is an excellent option, a warp drive is no way behind. A warp device is a hypothetical propulsion technology that would enable a spaceship to travel faster than the speed of light by bending the fabric of space-time. Some physicists think that it would be feasible to construct a functional warp drive using our existing knowledge of physics, even though this theory is still very much in the realm of science fiction. While these ideas are quite unique and need a lot of work, there is another option, which is to colonize space habitats rather than planets. Space habitat is a self-contained environment created to support human life in space. These habitats might be often found in the vicinity of asteroids, moons, or planets, and might be built from resources gathered from the asteroid belt or other regions of our solar system. Compared to planetary colonies, space habitats would have a lot of advantages. For starters, they wouldn't be exposed to the hazardous conditions that can make living on a planet difficult, such as harsh weather, geological activity, or other dangers. They might also be built with features like artificial gravity and regulated lighting to give people a more comfortable atmosphere. However, space habitat will also have unique difficulties, as it would need a steady flow of supplies of food, water, and air. Additionally, they would need to be built to withstand the harsh radiation conditions of space. Although there are considerable obstacles in the way of colonizing the galaxy, they are not impossible. We just have to build more efficient spaceships, locate habitable planets, and navigate a number of logistical and technical obstacles. But with perseverance, investment, and ever-improving technology, it might be possible for humans to colonize different stars in galaxies in the future. That is it from today's video. We hope you enjoyed the content of the video. If you did, show us some love and hit that like button, and don't forget to subscribe to our channel so that you will never miss out on any of the amazing videos we have in store for you.